For the first time, astronomers have been able to conduct detailed observations of a visitor that formed around another star, the interstellar comet 3I Atlas. It has been traveling through space for perhaps millions of years. New observations from multiple observatories are painting a chemical profile unlike anything we have an exact copy of in our own solar system. In this video, we will explore what scientists found, why it matters, and what it tells us about the chemistry of other star systems. Let's get started. Our solar system is a gravitationally bound island in the vastness of interstellar space. For almost all of human history, every object we've observed has been a member of our own solar family. On rare occasions, however, a traveler from the void between stars passes through. In mid-2025, astronomers confirmed we had another such visitor, named 3I Atlas. This is only the third time we have identified an object as being truly interstellar, following the discoveries of Oumuamua in 2017 and 2I Borisov in 2019. Each was a fleeting messenger, offering a priceless momentary glimpse into the chemistry of star systems beyond our own. But 3I Atlas presents a unique opportunity. As scientists turned their most powerful instruments towards it, they began to build a detailed picture of its composition. The data provides an invaluable sample of the materials that exist in other planetary systems, forcing us to consider the diversity of chemical environments across the galaxy. This makes the comet an invaluable opportunity for scientists to study the chemical building blocks available for planet formation elsewhere. The story began on July 1, 2025, when the Asteroid Terrestrial Impact Last Alert System, or ATLAS, flagged a faint, previously unknown object. As astronomers tracked its path, the numbers were unmistakable. Its orbit was not a closed ellipse, but a sharp, open-ended curve, a hyperbolic trajectory. This object was moving too fast to be captured by our sun's gravity. It came from interstellar space, and it was headed back there. Having been designated C/2025N1/Atlas, it was officially designated 3I Atlas. Immediately, a global campaign of observation began. From the start, it behaved differently from many comets we typically see. It was already active, sporting a fuzzy cloud of gas and dust called a coma far from the sun, hinting that its surface, long dormant during its journey through the frigid interstellar medium, was composed of volatile ices that vaporize at lower temperatures. To investigate the comet's chemistry, researchers used instruments like the James Clerk Maxwell Telescope, or JCMT. By analyzing the light from the comet's coma, the team identified the signature of hydrogen cyanide, or HCN, a molecule that serves as a building block for more complex organic compounds. JCMT observations indicated it was releasing this gas at a rate of approximately 2 kilograms per second. This finding immediately drew attention because it provided one of the first concrete measurements of outgassing chemistry from this new visitor. To unravel the chemical secrets hidden within the coma, astronomers pointed a fleet of observatories at 3I Atlas. The goal was to build a chemical portrait of the gas boiling off its nucleus. What they found was a compositionally diverse and evolving object. The data revealed the unmistakable signature of hydrogen cyanide emerging from the comet's nucleus. Hydrogen cyanide is a crucial molecule for building carbon-based compounds, a stepping stone to more complex organic structures. While its presence is not unusual for a comet, being able to measure it on an interstellar object provides a key data point for comparing systems. Another notable observation concerns the comet's dust. Analysis showed 3I Atlas was ejecting dust at a rate between 60 and 60 kilograms per second. More importantly, spectroscopic analysis from earlier observations revealed that the comet's reflected light appeared slightly redder than typical comets from our solar system. This red coloration supports the idea that the comet's surface chemistry has been shaped by different environmental conditions either during its formation or during its long exposure to interstellar radiation. This is one of the strongest indications that the comet carries a mixture of materials that likely formed under conditions that differ from those in the early solar system. So, what could explain this chemical signature? The answer lies in the comet's birthplace, orbiting a star we may never identify. The specific mix of volatiles and dust tells us something profound. The chemistry of planet-forming disks is not uniform across the galaxy. Different stars create planetary systems with different starting ingredients. This was further confirmed by world-class observatories as the comet continued its journey. After its closest approach to the Sun in late October 2025, observations with the Gemini North Telescope in November revealed that the comet's coma began to glow with a greenish hue. This is a classic sign of diatomic carbon, or C2, a gas that appears when cometary ices are broken down by sunlight. The initial lack of this gas when the comet was farther out, combined with its reddish dust, helps set it apart from our local comets and even the previous interstellar visitor, 2I Borisov. Taken together, these findings paint a clear picture. 3I Atlas is a chemically distinct object because it formed under conditions unlike those in our solar system. Its internal structure, molecular inventory, and outgassing behavior provide clues about the diversity of materials that can emerge in other planetary systems. For scientists, this makes the comet an invaluable opportunity to study the chemical diversity of planet-forming environments across the galaxy. The study of any interstellar object breathes new life into one of science's most tantalizing ideas: panspermia. Panspermia is the theory of life's fundamental building blocks can be distributed throughout the universe. The most plausible version of this theory, interstellar panspermia, proposes that comets and asteroids act as delivery vehicles for the essential organic molecules needed to start life. Think of it like this: the universe is a vast garden, and planets are patches of fertile soil. Panspermia suggests that comets like 3I Atlas could be one way these planetary patches get seeded with prebiotic ingredients. We believe cometary impacts on early Earth delivered a significant amount of the water and organic compounds that were critical for the emergence of life here. 3I Atlas provides direct evidence that this process is not just a local phenomenon. It proves that comets from other star systems, carrying their own unique chemical inventories, are traveling the galaxy. This does not imply 3I Atlas carries life, but it does strengthen the hypothesis that the raw chemical ingredients necessary for complex organic processes may be widespread and transportable between stars. 3I Atlas shows us that the delivery system is real. Whenever an object arrives from another star, the question of artificial origins inevitably comes up. Oumuamua's strange characteristics led some to seriously consider the possibility of it being an extraterrestrial artifact. Because of this precedent, scientists were on high alert. The Breakthrough Listen project, along with researchers using the Allen Telescope Array and the Green Bank Telescope, quickly directed powerful radio instruments toward 3I Atlas. They meticulously scanned the comet across a wide range of frequencies, listening for any technosignatures, any signal that appeared artificial. The result was unambiguous silence. After extensive scanning, the teams found absolutely no evidence of alien technology. But this finding doesn't diminish the discovery, it makes it more profound. If 3I Atlas were an alien probe, its composition would tell us about their technology. Because it's a natural object, its composition tells us about the universe itself. It confirms that the fundamental chemistry needed for life is something the cosmos creates naturally in star systems far from our own. The journey of 3I Atlas is a powerful reminder that we are part of a much larger cosmic story. The secrets it has revealed are just the beginning, and to continue bringing you these incredible stories from the frontiers of science, we need your support. If you find yourself captivated by the mysteries of the universe and want to stay updated on the latest discoveries, please take a moment to subscribe to our channel and turn on notifications. Your support allows us to keep exploring these profound questions together. As of late 2025 and into 2026, 3I Atlas is on its way out. Having rounded the Sun, its trajectory is now carrying it back into the interstellar void, never to return. But our study of it is far from over. Astronomers will continue to monitor it as it recedes, watching how its activity changes as it cools. 3I Atlas may not have been carrying life, but it carried something almost as important: evidence. It has given us our first concrete sample of the prebiotic chemistry at play in another star system, and it has shown that the building blocks of life are not a unique feature of our own cosmic backyard. This discovery is a game changer. The question is no longer if the ingredients for life exist elsewhere, but how diverse their chemical environments are. We will soon have the tools to find out. The upcoming Vera C. Rubin Observatory is projected to discover many more interstellar objects, turning these rare events into a steady stream of data. We stand on the cusp of a new era where we can begin to piece together the story of life's origins, not just on Earth, but across the galaxy. 3I Atlas was just the latest messenger, a comet reminding us that the chemistry that led to us is happening around countless other stars.